To define recrystallization, it is a common purification technique used to purify solid compounds. There's a couple of other purification techniques which are called distillation and extraction, but the one we're focusing on is mainly recrystallization. This process involves a compound meaning to be purified, in this case benzoic acid, which is dissolved within a suitable hot solvent, in this case deionized water, and subsequently filtered with activated charcoal and finally left to cool slowly to room temperature to fully crystallize. Some real-world examples of recrystallization apply to scenarios where the substance being purified has a fairly large amount of impurities that need removing. This process can work well as a sort of final cleanup step in purifying a desired substance, and it can be seen in things like making salt crystals or various types of sugar used for cooking. As this involves filtration of solutions, there's going to be multiple conical flasks involved. In the photo to the right, there's a vacuum filter setup that is one of the final steps in the recrystallization procedure, where you will use a special sort of funnel to filter off the benzoic acid crystals. In the image on the left, there's a solution of hot benzoic acid and activated charcoal, and that's being filtered into another conical flask while still being kept hot in order to make sure it doesn't crystallize early. Due to the nature of recrystallization and the equipment used, there can be some risk involved. In this case, there's the possibility of broken glassware from any of the glass equipment, possible burns from the hot equipment, or possible exposure to the benzoic acid. The chances of all these are relatively low if appropriate PPE is worn in the laboratory, specifically things like heat-resistant gloves whenever you're handling the glassware when it's really hot. The first step needs you to choose a solute. In this case, it's the impure benzoic acid being recrystallized. Benzoic acid is a good choice for this as it manages to dissolve in high temperatures and eventually crystallizes when cooled. You will also need a suitable solvent, in this case water, since it shouldn't react with the compound being purified. Benzoic acid also must be soluble in the water when hot and less soluble when cold to recrystallize well. The video in the following slide depicts the color change seen when the impure benzoic acid is added to the hot water in the conical flask and stirred to help with dissolving. This step requires a filtering and decolorization of the solution through use of the activated charcoal. The colored soluble impurities are removed through adding the coal. Then, with another conical flask, which is still being kept on the hot plate, the coal solution is poured through a funnel with filter paper into another flask, all while being kept on the hot plate to prevent early crystallization. The subsequent filtrations with filter paper and activated charcoal removed more and more colored soluble impurities from within the solution until it became transparent and colorless. In the first filtration, you can kind of see how there's still a bit of a pink/red tinge to it, and from the second filtration you can see it's turned colorless and basically clear after all the impurities have been absorbed by the coal and the filter paper. The third step requires cooling to room temperature before placing the conical flask in an ice bath. Once the solution is around 4 degrees Celsius, you can set up the vacuum filtration for the final step for the recrystallization. This uses the funnel that I mentioned earlier, which is actually called a Buckner funnel, with filter paper inside. And this is basically a porcelain funnel with a bunch of holes in it, and it's used to separate the crystals from the solution and give you pure crystals in the final conical flask. Finally, the fourth step requires the filter paper covered in the crystals to be put on a watch glass, which is basically just a curved, transparent piece of glass, and left to air dry to room temperature. In our case, we didn't do that, and we put the crystals from the filter paper on the watch glass in an oven at around 80 degrees for approximately 10 minutes. And the final product was a small amount of pure benzoic acid crystals on the watch glass. In the end, the benzoic acid crystals produced should be pretty clear and fine, and not really a huge amount. But this entire process should now show you how to recrystallize a solid compound, and you can not only apply this to benzoic acid, but a range of other solid compounds for possible future lab work or research, and how to perform this sort of purification procedure safely and correctly. Also on the right is just a little reference image for the benzoic acid crystals from Wikipedia, and that just shows how clear and fine they are. From this particular procedure, you might not get such a huge amount that's seen in the image, but it's still the same sort of appearance.